To crash a project means to complete it in less time than normal. Crashing almost always costs money, literally. So the best way to crash a project is generally the least expensive way to crash a project. That is exactly what we need to figure out here. Epic Scenic Studios has learned that its project is needed in 7 days, and so plans are being drawn up to meet this new deadline. Oh, should note this. From last time, the scenario before, we had determined that the normal time for this project was 10 days. We had worked on this before, and what I mean by the normal time is we'd worked on this before with some reasonable estimates of how long each one of the tasks is going to take. And the natural conclusion of the entire analysis was that the whole project was going to take 10 days. Now, this scenario is following up with this new fact that 10 days is not good enough. We have to get done in 7. All right, fine. What should we do? Okay, now what is the additional information? They're saying that 4 tasks can be crashed. That means 4 of the various tasks, because this was the network from last time, 4 of the various tasks could be completed in less time than we originally planned on, which is what you can see displayed here in this note frame. Let's see, an F, right, yeah. So these are the candidates. These tasks could be shortened. They could be shortened by, some of them, just 1 day. See how, like, I'm just looking at the bottom one, paint the stage. It normally was going to take 2 days. That's what we planned on. Its crash time is 1 day. That means that we could shorten it down to 1 day, but we can't shorten it any more than 1 day. And we have to keep that in mind. But you could cut it from 2 days to 1 day for that one. The one at the bottom is one of the less expensive ones for $800. Now, should we do that? How do we know? Okay. There's a couple principles we have to remember as we tease out an answer for Epic Scenic Studios. What should they do about this new 7-day deadline? The first one is that you crash a project by crashing each one of its paths if needed. You go, huh? What? Well, just hang on to that thought for a second. Okay, because also you crash a project, sort of second principle, by crashing it 1 day at a time. Notice that Epic Scenic Studios needs to crash their project by 3 days, right? We're going to normally be 10 days and they want 7. We're going to figure out the best, least expensive way for them to crash it by 3 days by first figuring out the best way to crash it by 1 day. And then figuring out the best way to crash it by 1 day. And then figuring out the best way to crash by 1 day. You say, why? Isn't this going to make it kind of a long analysis? The answer is the first thing I said. You'll see this. It has to do with the effect on the paths. Oh, all right. Now, anyway, how do you actually do this? Here's what you do. You say, all right, where are we right now? I want to list all the paths. Take my word for it, we need to know this. All of the paths through this network. Now, path is any route from start to finish, right? One of them is pretty short. You could go A to, I'm just following the arrows, E to I, that connects to the finish. That right there actually is a path through this network. Another path through this network is, well, you could go to A, but then turn right and go to C, then go to F, then go to G, then go to H, then go to I. Okay, let's list that. A, C, F, G, H, and I. And then a third path is you could go to B, then to D, then to G, then to H, then to I. In this particular project, there is only 3 paths. Oh, phew, good, because we have to keep an eye on all paths. We have to keep an eye on all the paths, but we haven't even decided anything yet. The next thing that we need to do, and I mean, we're still just starting, is we need to calculate the length of each one of these paths. Oh, all right, length. Well, the length of the path is the sum of the durations along the path. For instance, A, it was 1 day long. E was 1 day long. And I was 1 day long. We would say that that path, AEI, is 3 days long. See? Oh, okay. Now, A is 1 day long. C is 4 days long. F is 2 days long. G is 1 day long. H is 1 day long. I is 1 day long. A, C, F, G, H, I adds up to 10 days. Then down here, B is 3 days long. D is 2 days long. G is 1 day long. H is 1 day long. I is 1 day long. That adds up to 8 days. And say, all right, I did it. I have the length of each of the 3 paths. Oh, and even if you don't remember working on the scenario before this one, at this point you can recognize the critical path through the network, because we remember that the critical path through any network is the longest path through the network. A, C, F, G, H, I, when we tallied it, that was the biggest number. That's the longest path. Oh, 10 days. Where did I get my original statement that we were originally planning on a normal time of 10 days because the critical path is 10 days long? Right, that's where that number came from. Oh, all right, now, big number that we're interested in here is 7. How can we get this whole project down to 7 days? Okay, we're going to do that. But we're going to do that by asking a slightly different question first. How can we get the project down to 9 days? It's at 10 days right now. What is the best way to get this project down to 9 days? What is the best way to crash this project by one and only 1 day? Well, to crash this project to 9 days, maybe I'll write a little note here. Target 9 days. I need to look for any path that's currently longer than 9 days and look for a way to reduce it to 9 days, because a project is not done until each of its paths is done. Now you can see that this question deliberately 9 days. There is only one path that is currently, under normal conditions, longer than 9 days. That is ACFGHI. That's the path we have to crash. We have to figure out a way to shorten that path by 1 day. Oh, right, and that was the critical path. Right, to shorten a project, to crash a project, you have to crash the critical path. Oh, okay, now we just need to figure out the best way to do it. I keep saying best. Remember, best here is least expensive. What's the least expensive way to cut a day out of this path? Well, I look at our options. B, right? B, never mind what B costs. You notice the test B isn't even on this path? That's not going to help. C, oh, C is on this path, and we could definitely shorten it. It's $2,000 per day. If we shorten C by 1 day, the whole path would shorten by 1 day. That'd be great. But before we decide, let's look at some of the other options. D isn't on the critical path. It doesn't matter. The D is the least expensive, very attractive price, but it's not going to help. F is on the critical path here, and F is considerably less expensive than D. I think we just made our first decision. Decision. Shorten F. Crash F by 1 day. Okay, so F, that's not going to be 2 anymore. That's going to be a 1. Now what do we need to do? Now we've figured out how to get this project down to 9 days. That's great. Next step, now that we're at 9 days, how do you get the project down to 8 days? Oh, well, you know what? We'd better look at the paths again. Okay, this was normal. If you've got the note frame, this is just that same network, right? So that we've got it for easy reference. We need to start over. Sort of. Not exactly over in the truest sense. It's the same paths. C, F, G, H, I. These don't change. B, D, G, H, I. Except that we did decide that now F is only 1 day long. So what are the lengths? Okay, well, the length of A didn't change, E didn't change, and I didn't change. So the length of AEI didn't change. That's still 3 days. The length of A didn't change. We just said that. The length of C didn't change. It's still 4 days long. F changed. F is now only 1 day long. G, H, and I didn't change. So we've got now a 9-day path through the center. B didn't change. D didn't change. G, H, whoops, that's a 1. 1 plus 1, G, H, I. None of that changed. So that's still 8 days. Okay. This project right now is now 9 days long because its longest path is 9 days long. Pick a new target, 1 day less. Well, that means I'd have to shorten that by another day, right? This is at 8 days, this BDGHI, so that wouldn't be a problem for an 8-day target, but the critical path is still a problem. We need to shorten the critical path again. We just repeat this logic. We say, okay, let's see, cheapest way to shorten that same path. Well, last time F was the cheapest, so why don't we just shorten F again? Well, we can't. We can't because the crash time for F is 1 day, right? It is at 1 day right now, meaning that, and that's what we mean by crash time. Crash time is the absolute shortest that you can make something. You can shorten a task and not necessarily shorten it all the way to its crash time, but you can't shorten a task beyond its crash time. F is tapped out as an option. Oh, so you remember from last time, the only other option that worked in shortening that path was C, the really expensive one. It's the only option we have left. So we're ready to make a decision, even if we don't like the price. The decision, shorten or crash C by 1 day. Okay, so that's no longer a 4, that's a 3. You say, all right, now what? We figured out how to get it down to 8 days. Now we ask the third question. Now that it is at 8 days, how do we get it down to 7? All right, well, it's the same paths. That doesn't change. AEI, ACFGHI, BDGHI. What has been changing as we have been shortening tasks is the length of the overall path, although not in the case of AEI, right? Because we haven't touched any of those 3 tasks, so that's still 3 days long. Now wait, ACFGHI, A is still 1 day long. C is what we chose to shorten last time, so C is no longer 4 days long, it is now 3 days long, right? That got shortened. Plus F is still at its shortened 1 day long, plus we didn't do anything to those other tasks, so this is the new length. So this is 5 plus 3, 8 days. And then 3 plus 2 plus 1 plus 1 plus 1. We didn't touch anything along this path, so it's still holding at 8 days. So yeah, okay. But our target now is 7 days. Now we want to cut 1 more day off this project. You say, all right, fine, let's find another way to shorten ACFGHI. Yes, except notice that it's not the only problem anymore. a project is not finished until all its paths are finished, we could, for instance, the only way actually to shorten ACFGHI is to go back to C again. Luckily C, although it was expensive, notice that the crash time is 1 day. Its normal time is 4. We've knocked it down to 3. There's still plenty of room there if we want to keep shortening it, and that will keep shortening that particular path. It's true. But shortening that path, like changing this 3 to a 2, might change this to a 7, but it won't change the project to being 7 days long because we have to also shorten this sequence. Now, what would be really cool is if there was a way to shorten one of these tasks that the two paths share, like G, H, or I, provided that it was a reasonable price. Because if you could shorten one of those tasks by a day, both those paths would shorten automatically. Problem is, go back and look at the original information. Well, those are pretty short to start with, and so they simply can't be shortened anymore, right? They're not one of the options. So the only option for shortening ACFGHI, we can make half of our decision here, is we're going to have to shorten C again. That will address that one, but we've got to come up with a solution also to shorten BDGHI. What would work? Well, it would work if it's on that path. Oh, B is on that path. B could be shortened. The cost is 1,000. And D is on that path. D can be shortened, and the cost is 500. I definitely prefer to shorten D. That would create a situation, path A, E, I, length, down here. That one would still be 3 days, but A, C, F, G, H, I would then become 1 plus 2 plus 1 plus 1 plus 1 plus, there's 4 ones, right? Yes, 4 ones, or 3, 7. And then because of D, B, D, G, H, I, we're looking at 3 plus 1 plus 1 plus 1 plus 1. Some of these tasks are just as short as they can get. That would work. See? Everybody is 7 days long or shorter success. 7-day completion time. Now, at this point, we have actually figured out how EPIC should proceed. We might as well sort of like roll that up into some more explicit recommendations, just to say, gather together from all our scratch work what it was that we actually decided. EPIC should, let's look at what the decisions were. Shorten or crash F by 1 day. Let's see. And then C, and then C again. So C by 2 days, right? C by 2 days, because we decided twice. And D by 1 day. And oh, by the way, total cost then, because that's what we were trying to minimize. Let's see, F, when we shortened F, we spent $800. When we shortened C, we spent $2,000 per day, so we spent 2,000 times 2 or $4,000. That was really expensive. And then when we shortened D, I'm just looking at the data. When we shortened D, we only spent $500. So the total cost of our crashing plan, whoops, whoa, that would have scared them. I put one too many zeros. It's $5,300. So EPIC should shorten F by a day, C by 2 days, and D by 1 day, spending $5,300. Why? This will enable them to get the project completed in exactly 7 days.